At the moment, we're watching 20,000 games played by an AI as it explores the world of Pokémon Red. At first, the AI starts out with no knowledge and is only able to press random buttons. However, over 5 years of simulated game time, it acquires many skills, learning from its experiences. Eventually, the AI manages to capture Pokémon, evolve them, and defeat a gym leader. At one point, she even manages to exploit the game's random number generator. But perhaps more fascinating than its successes are the ways in which it fails, which surprisingly relate to our own human experiences. It turns out that studying the behavior of an algorithm can actually teach us a lot about ourselves. In this video, I'll tell the story of the development of this AI by Peter Whidden, and we'll analyze the strategies it learns. The project reference link, as always, is in the video description. In another video, I'll go into some technical details and show you how to download and run the program yourself. And how did the project come about? Well, the AI interacts with the game in a similar way to a human being, capturing images of the screen and deciding which buttons to press. It optimizes its choices using something called reinforcement learning. With this method, we don't need to explicitly tell the AI which buttons to press. We just need to provide high-level feedback on how well it's playing. This means that if we assign rewards to the objectives we want them to complete, the AI can learn on their own by trial and error. The AI starts with no knowledge or skill and can only press random buttons. To provide useful feedback, we need to create a curriculum of rewards that will guide her in learning challenging objectives. A basic goal to start with is to explore the map. We want to reward the AI when it reaches new locations. More generally, we want to encourage curiosity. One way of doing this is to keep a record of all the screens the AI has seen during the game. We can compare the current screen with the screens in the log to see if there are any close matches. If no matches are found, this means that the AI has discovered something new. We'll then give them a reward and add the new screen to the log. Rewarding the AI for unique screens should encourage them to find new parts of the game and look for new things. Now, with the objective clear, we can start the learning process and see how it works. At this stage, the AI is basically pressing random buttons just to see what happens. To gain experience more quickly, the creator has programmed it to play 40 games simultaneously, each for 2 hours. The AI reviews every game and updates itself based on the rewards it has earned. If all goes well, we'll see incremental improvements, and the whole process can be repeated. After a few iterations of training, the AI finds a way out of the initial room noticeably faster than when its behavior was random. However, instead of exploring Route 1, it becomes fixated on a specific area of Pallet Town. Why does this happen? Well, it's because when you're looking for something new, it's easy to get distracted. The area she's stuck in has animated water, grass, and NPCs walking around. This animation is enough to trigger the novelty reward many times. Therefore, according to the objective itself, staying there and enjoying the scenery is more rewarding than exploring the rest of the world. This is a paradox we face in real life. Curiosity leads us to our most important discoveries, but at the same time it makes us vulnerable to distractions and problems. As human beings, we can reflect on our own sources of intrinsic motivation, but we can't easily change them. In contrast, it is simple for us to change these sources of motivation for an artificial intelligence. Returning to the current scenario, A reward is triggered if more than just a few pixels differ from the screens seen previously. However, if we increase this threshold to several hundred pixels, the animations will no longer be enough to trigger the reward. This means that the AI will no longer get satisfaction from watching them and will only develop an interest in really new places. Note, each time the author modified the rewards, he restarted the AI's learning from scratch because he wanted the whole process to be reproducible. After this change, the AI starts exploring Route U and eventually reaches the city of Viridia. This is great progress, but now another problem arises. In most battles, the screen looks pretty much the same, so there aren't many exploration rewards to be had during battles. This causes the AI to simply run away from them. However, it can't progress without battling. To deal with this, the author put in additional rewards based on the combined levels of all your Pokémon. Now, with this new incentive to gain levels, the AI gradually starts winning battles and capturing Pokémon and evolving them. Eventually, your Pokémon reach a high enough level to start evolving. At first, the AI tends to cancel evolutions before finally deciding that it is beneficial. However, it seems to get stuck when the Pokémon battles long enough for its standard ability to run out. Despite this, after many iterations of training in version IV, there is substantial progress. At this point, we see a Pidgeotto being evolved for the first time. And finally, the AI figures out what to do when a skill runs out and manages to switch to an alternative skill. This will prove crucial for something that happens later on. In version VAX, the AI begins to enter the Viridian Forest and starts its first trainer battles. At this point, it has enough experience to succeed in its first encounter. After that, it slowly begins to understand how to navigate the forest. Finally, in version XXV, she discovers how to cross the forest and head towards the city of Pilter. But something still wasn't right. Despite all the progress, the AI was walking straight into battles, even ones it couldn't win. Worse still, it never visited a Pokémon Center to heal, which meant that when it lost, it was taken back to the beginning of the game. The author tried to fix this by subtracting rewards when she lost the battle, but this didn't work as expected. Instead of avoiding difficult battles when it was about to lose, the AI simply refused to press the button to continue the battle, entering an indefinite stalemate. This technically serves the purpose, but it's not what the author intended. While the author was studying the effects of this, he noticed that, on very rare occasions, something else was subtracting a large amount of reward just once every training session. In a single game, there was consistently a reward 10 times greater than the author intended to be deducted. Replaying the moment before this happened, we see the AI entering a Pokémon Center and approaching a computer in the corner. After logging in and pressing buttons randomly for a while, it deposits a Pokémon into the system, and immediately a large amount of reward is lost. This is because the reward is awarded based on the sum of the Pokémon's levels. So depositing a level the 3rd Pokémon means instantly losing the 3rd levels. And this sends such a negative signal that it causes something akin to a traumatic experience for the little AI. It doesn't have emotions like a human being, but a single event with an extreme reward value can still leave a lasting impact on its behavior. In this case, losing your Pokémon just once is enough to form a negative association with the Pokémon Center as a whole, and the AI will avoid it completely in all future games. The root cause is that the author never considered the unexpected scenario in which total levels could decrease. To solve this, he modified the reward function so that it only gives any reward when levels increase. This seems to fix the problem. After restarting training, the AI starts making visits to the Pokémon Center. Finally, we see it starting to challenge Brock in the pewter gym. This battle is much more difficult than the previous ones and represents a significant challenge because the AI's previous experience is now working against it. Up to this point, she has had great success using only her primary moves and has learned to rely on them exclusively. Now, it needs to use something different. This problem may seem trivial, but even humans struggle with the same fundamental problem. Our experience and biases help us make decisions and solve problems faster, but they also limit our thinking and hinder our ability to approach a problem in a new way. To make matters worse, if the AI loses the battle too many times, it will learn to avoid it altogether. But after the author carefully adjusts the rewards and numerous failed attempts, the AI finally gets lucky in one of the games. We see it start the battle in the gym with only one usable Pokémon that has only a fraction of its life points and moves available. Normally, this would be a terrible strategy, as she doesn't know that a water-type ability will be super effective against the rock Pokémon. However, because the tackle move is totally exhausted, she realizes that she needs to use an alternative move and switches to Bubble. Finally, after more than 300 days of simulated game time and 100 learning interactions, the AI defeats Brock for the first time. This accidental breakthrough helps it learn to choose Bubble as its default move, and in future games, it wins this battle more consistently. This exceeded the author's expectations, going beyond what he expected to be possible. It took a great deal of experimentation to get to this point, and with each new area reached by the AI, the author was amazed. I would venture to say that it was a very rewarding experience. So here seems like a good stopping point. But, out of curiosity, let's see how far the AI will let itself go after the battle in the gym. It starts meeting trainers on Route 3 and eventually arrives at the entrance to Mountain Moon. Inside the Pokémon Center, a man is selling a Magikarp for $500. Magikarp is not useful in the short term, so you might expect the AI not to be interested in it. However, buying it is a super easy way to gain 5 levels, so the AI buys it every time. Over the course of all the games, it buys a total of more than 10,000 Magikarps. The AI's behavior can seem silly when its goal deviates from its original purpose, but there are times when the same thing happens to human beings. For the AI to progress in the game, the author configured it to find ways to increase its levels. Similarly, evolution selected humans for survival as hunters and gatherers, which naturally set us up to find ways to acquire scarce food. When the AI arrives in an area with cheap and useless Magikarp, it buys the Pokémon every time, as this increases its total levels and gives it rewards. And as humans reach our modern age of abundance, we instinctively buy unhealthy food, because it contains the historically scarce nutrients. Each of these indirect goals arose from very different circumstances. But when their environments changed, both became misaligned and no longer supported their original goals. Next, the AI begins to explore the cave inside the Mountain Moon. That's the point. It has fought all the wild Pokémon it has encountered, but Magikarp is so ineffective that it eventually learns a special behavior just for that Pokémon. If Magikarp has been sent into battle in any situation, it will try to run away, no matter what, sometimes even during a fight against a trainer. Despite exploring a large part of the caves, it seems to get stuck in this corridor. possibly because the area is too visually uniform to trigger the exploration reward. The author has tried to extend the games to last more than 2 hours. The AI is able to evolve the Pokémon into Blastoise and Pidgeot, but it never manages to get through Mountain Moon completely. I'll stop here, and in the next video I'll continue with an analysis of what the AI has learned so far and its playthrough to the end. Thanks for watching this far and for your generous support, and I'll see you next time.